We recently learned how to multiply powers with like bases, and today I want to take a look at how we compute quotients of powers. And we're going to focus on like bases at first, and then we'll mix it up and see if we can do any simplifying with powers that don't have like bases. So just like when we introduced multiplication, we're going to start with a simple division problem, something like 3 to the 6th divided by, let's say 3 squared. And we're going to start by talking about what this means. Well, we know that this 6 exponent means that we're going to write down 3 6 times, and we're going to multiply those. And if you're like me, you do not want to multiply 3 6 times. So we'll leave it like that for now. On the bottom, you may be tempted to multiply 3 twice, because that's easy, it's right off our times table. But let's just write down what this means. It means that we're going to multiply 3 twice. And so when we do that, we remember that when you're dividing and you have a quotient and you have the same value on the top that you do on the bottom, those divide and turn into 1, so we say they cancel. So I'm going to cancel these 3's, and I'm going to cancel these 3's. And you'll see that what I'm left with is just 3 multiplied 4 times. And we know what that means, because I still don't want to multiply that out, but I can write what it means in a simpler way. It means 3 to the 4th. Now, just like before, what we'd like to do is we'd like to make up a rule, a recipe if you will, that starts with the original problem, skips all of this writing that we don't want to do, and ends up with the value, the answer, the result. And I think you'll agree that it looks like what happened is we had 3 to the 6th divided by 3 squared, and we ended up with 3 to the 4th, meaning that these exponents were subtracted. And that turns out to be the rule. The rule is when you're dividing powers with like bases, you simply subtract the exponents and you end up with a power. That's the result. Later, if you feel like it, you can multiply that out, right? 3 to the 4th power is 81, but that's not our concern right now. And this will work with other bases like variables as well. And so if we wanted to do x to the 7th over x to the 5th, we'd simply do x to the 7 minus 5, which is x squared. And eventually we won't even want to do this. We'll just do 7 minus 5 in our head and write down the power. Okay, so it looks like we've got a plan here. I'm going to pause while you jot this in your notes. If I didn't mention it, I do want you to jot this stuff down in your notes. And then we'll take a look at how your book describes this. So example 1 in lesson 7.4 talks about the quotient of powers property. And sure enough, they've described exactly what we discovered. That if you're dividing non-zero powers with the same base, the way we divide those is subtract the exponents and write the power with that new exponent. So we've got an example with numbers right here, and the same example with variables, which we'll get to later. Okay, so now what we're going to do is run through several examples. Each of these should be included in your notes, and one of them happens to be a problem straight from your assignment. So it'll be good to have those jotted down. So we'll start with 2 quick examples, and then I'll pause for you to make sure you have them in your notes. Now we're going to do 3 to the 8th divided by 3 squared. Everybody knows that 8 minus 2 is 6, so our result is 3 to the 6th power. And since I don't feel like multiplying that out, I'm going to leave it as 3 to the 6th power. Let's quickly do x to the 5th divided by x to the 5th. 5 minus 5 is 0, so that's x to the 0. Oh, but we've seen this before. We're raising x to the 0 power, and we know that result's going to be 1. So let's make sure that we simplify that one. Even though I said I didn't feel like simplifying 3 to the 6th power, I definitely want to simplify x to the 0. So as usual, what we do after we practice the rule a little bit, we step it up a notch and we start to use the rule in the context of other rules that we've worked with. So here we have a to the 5th, b to the 9th divided by the quantity of ab raised to the 4th power. So before we can use our subtraction rule, we have to deal with this expression down here with the parentheses. Remember, what we do is we apply this power. It kind of feels like distributing. We apply the power to every factor in the parentheses. So before we do our quotient property, we're going to rewrite this a to the 5th, b to the 9th, because I didn't mess with the top. On the bottom, I'll have a to the 4th, b to the 4th. And now I can do my property. Remember, this is for like bases, so we're going to do the property with the powers that have a as the base first, and that would be a to the 5 minus 4. And I'm going to write out what my brain is doing here for now. And then this one would be b to the 9 minus 4. And finally, we can write out this new expression. 5 minus 4 is 1, so that's a to the 1st power. We typically don't write the 1 down, though. We'll just write letter a. 9 minus 4 is 5, so that would be b to the 5th power. And then when you write these expressions, go ahead and list your variables in alphabetical order. Since they're all factors, we're allowed to move them around because multiplication is commutative. So just remember, if there's extra math, in this case, a product of powers, a power of a product, you have to take care of that first before you do the quotient property. Make sure you have that one jotted down. It may come back on you later. It's not unusual to see quotients where there are several powers listed. And again, we're not going to panic. We're just going to take them one at a time. So this is 2 as the base. And remember, there's a little 1 on this guy, even though we don't write it. So this is 3 minus 1, which is 2, or 2 squared. The 3's will be 3 to the negative 2, because 2 minus 4 is negative 2. And then the 5's are 7 minus 5, which is squared, so this is 5 squared. All right, now, we really aren't allowed to keep our answer written this way because we like to remove the negative exponents. So don't forget that. What happens is that thing belongs in the denominator. So I have 2 squared times 5 squared over 3 squared. And as I mentioned in class, we can usually square things pretty easily, so we're not going to leave this as powers. I do feel like multiplying this out. This is just 4 times 25 over 9, which is 100 over 9. That fraction does not simplify. I do not mind if you leave it like that. Improper. 100 over 9 is the value. Here's one more quick example. See if you can race me. 9 minus 7 is 2. 2 squared, that one's easy enough. We'll just do it. The answer's 4. Just threw that in to see if you're paying attention. And who knows, it might show up on your assignment. This one looks deceivingly easy, but we're going to be careful. First of all, a variable by itself is really raised to the 1st power. So we can write this as a power y to the 1st divided by y to the 4th. We're going to subtract exponents. Be careful. 1 minus 4 is negative 3. And remember, we don't leave these expressions with negative exponents, so I have to write that in its fraction form. In this case, that would be 1 over y cubed. And that's going to be the result for that division. Just a few more examples left here. I want to make sure I'm covering everything. Each of these should be in your notes. I've mentioned that before. Notice before we work on this problem with the quotient, we're going to have to deal with this power on a power. Remember that our rule says if you have a power and you raise that to another power, you're just going to multiply the exponents. So we do not mess with the numerator. It's still m to the 5th, n to the 4th, but that m to the 5th squared is going to become m to the 10th. And then don't forget this n down here with m to the 10th still has a first power on it. Now we can do our quotients. We'll do the m's first. Be careful. This is m to the negative 5 because 5 minus 10 is negative 5. Oops. This is m to the negative 5. There we go. We'll throw that in a blooper reel. 4 minus 1 is 3, so that's just n cubed. And then, as you know, we're not going to leave this guy with a negative exponent. Instead, we'll write it in the denominator. So this is n cubed over m to the 5th. And that'll be the result of that division. Just pausing so you can get it in your notes. The problems start to get more complicated as we throw coefficients and extra variables in there. But we're not going to panic. We'll deal with them one at a time. So one of the things I want you to know is when we throw a coefficient in here, we're going to deal with those separately. And whenever there's no coefficient in place, you can always assume there's a 1 in front. So xy squared really has a 1 out in front for a coefficient. And so what we'll do is we'll divide these two numbers first. They're just coefficients. We're not subtracting them. We're just going to divide. And I think you know that 2 divided by 1 is just 2. Then remember that these x's both have the first power on them. So this is x to the 1 divided by x to the 1, which is x to the 0. 1 minus 1 is 0. And in a minute we're going to turn that into a 1. And since there's nothing here to subtract for the y squared, that thing stays on the bottom in the denominator. There is no other power to divide y squared with, so it just stays put. And then the last thing we're going to do is realize that this x to the 0 is really just a 1. 2 times 1 is 2, so the result on this quotient is 2 over y squared. Another way to think of this problem is we just cross the x's out, and we end up with 2 over y squared. So you can think of it a little longer the way I originally did it, or you can just cross out the x's and get this 2 over y squared. Last but not least, here's one more example where we've thrown coefficients into the mix. As I mentioned, the first thing we'll do is we'll divide 3 by 4, except they don't divide, right? They do divide, but we get a decimal, so we're not going to mess with a decimal. So if there's a fraction there and you can't divide the two numbers, just leave it as an improper fraction. Or actually, this isn't improper. Just leave it as a fraction that's reduced. How's that? Next thing you'll notice, we have v to the 4th and v squared. When we do 4 minus 2, we get v to the positive 2. Remember, if it's a positive exponent, it stays in the numerator. And then this u squared doesn't have a power that will divide with it, so we're going to leave it on the bottom as u squared. And this is as close as we can get to a simplified answer. There's no other simplifying we can do. So this thing stays. Again, the fraction stayed 3/4 because we can't divide 3 by 4. So just leave those numbers in their place. V to the fourth divided by v squared. 4 minus 2 is positive, so v squared stays on top. It doesn't have to move because it didn't turn negative. The exponent didn't. U squared had nobody to divide with, so it stayed in its position in the denominator. So 3v squared over 4u squared, that's it. Okay, so that's it for the video. Please tell me that you have all of these copied down because you're going to use those notes to run through the first part of the assignment. And then you'll still have them for the second part as well. Good luck with the quotient of powers property. And I'll see you soon.